Good morning, children. I welcome you all to today's session of physics, and we are on to chapter 5, which is light. And we have seen that light is a form, right, children? Remember, this is a very, very important thing for you all to know, and that is light is a form of energy, right? Which enables us to see. Now, sources of light, there are various sources, right? Luminous and non-luminous object. In that we also saw what is bioluminescence, right, which is the cause of the firefly shining during nights. We also saw what are transparent materials through which light pass and we can see, translucent materials through which some light can pass and we can partially see, very can pass nor we can see. Then we also went on to see the linear propagation of light, which is a very important phenomenon as far as light is concerned, which clearly says that light travels in a straight line. And not only that, children, we also saw that the speed of light is 3 into 10 to the power 8 meter per second. We also went through these experiments to show that light travels in a straight line. And then we also went on to see what is a pinhole camera, or the ancientest camera, which works on the principle that light travels on a straight line. And we also saw this diagram, what pinhole camera is all about, how the image is formed here, and it's time now to move ahead, right? Now what are the characteristics of image formed by the pinhole camera? You can see from this diagram here that the image formed here is inverted, right? And see its size. Children, see the size of this tree and the size of this image. The image is reduced, that is slightly diminished, right? Slightly diminished. And more importantly, see children, uh, these line that the upside down image of an object formed by a pinhole camera is called an inverted image, right? It is an inverted image, right? Now, factors on which the size of the image produced depends upon, right? So here there is also one line, a pinhole camera forms a real and inverted image. See children, here real and inverted image. Now the factors on which the size of the image produced, it depends upon the size of the image formed by a pinhole camera depends on the distance of the object from the camera. See children, it is the distance here referred to is this, from here to here, this distance, right? This is being referred to here. The size of the image formed by a pinhole camera can be smaller than the object, equal to the object, or bigger than the object, depending upon the distance of the object from the pinhole camera. The farther the object from the pinhole camera, the smaller will be its image. Now these are the golden lines here, which you need to remember, right? Okay, now this is another way of forming a pinhole camera. Materials required are, you can see this and you can try it out, right? And let us move ahead to the wonderful world of shadows, right? When an object is placed in front of a source of light, it produces dark area behind it. The shade cast by an object is called its shadow. Shadows are formed when light is stopped by an object. See children, in this image you can see here, this is the shadow, right? Because somewhere here there is sun, right? Somewhere here there is sun, like this, and the sun rays are falling straight to this person, right? And the shadow is being formed. Okay, an opaque object, so this object here, it needs to be opaque, right? An opaque object stops the light completely, so an opaque object casts a dark shadow behind it. The translucent object stops light partially, so a translucent object casts a weak shadow, right? Translucent object casts a weak shadow. A transparent object does not stop any light from passing through it, so transparent object does not cast any shadow. An object forms shadow on an opposite side of the source of light. Remember this, the shadow is always formed on the opposite side, not on the same side. Right? Shadows of objects are usually similar in outline to the objects, and hence we can identify the object from these shadows. Right? So now it is the sun which generally forms the shadow. Right? You can see sun forming shadows. Right? When it falls, if we stand in sun, our body casts a shadow on the ground, and when we walk in the sun, our shadow always walks with us. Our shadow is very long in the morning when the sun rises, and the length of the shadow goes on decreasing till noon. Our shadow is shortest at the noon. The length of our shadow starts increasing in the afternoon, and our shadow becomes very long in the evening, just before sunset. Right? So you have seen this also. Now we must move to this very important part. From this discussion, we can conclude that we require three things, children. This is very, very important. We require three things for the formation of shadow. What are these three things? A source of light. B, an opaque object to obstruct the path of light. And C, a screen in which the shadow needs to be formed, right? If any of these three is not there, then the shadow will not be formed, right? Okay. Now this is an activity of shadow formation, right? They take a key in the hand and then put one torch at some distance from this, then throw light from it onto the key, and the shadow will be formed on the wall, right? Now the shadow of an object has the following characteristics. The shadow of an object is erect, same side up as the object. The shadow of an object is real because it can be formed on the screen. Irrespective of the color of the object, the shadow is always black. And then the shadow can be smaller than the object, equal to the object, or bigger than the object. Nice. See, so children, these 4 points are very important. We should know they are the characteristics of the shadow. A shadow can also be formed on a screen. A shadow consists of two regions. Central dark region is called umbra, and the outer partially dark region at the edges is called penumbra. Umbra is the region where no light enters. Penumbra receives some light, right? So umbra will be the position where the shadow will be the darkest, and penumbra will be the place where the shadow will be the lightest. See, you need to learn these much by heart. The formation of umbra and penumbra depends upon the size of the light source and distance between the object and the screen. Children, you will be surprised to know that the eclipse occur due to umbra and penumbra, right? Now earth and moon are opaque objects. Both receive light from sun. When sunlight falls on them, they cast shadow. When the earth, the moon and the sun form a straight line, the one which is in the middle receives the sunlight, whereas the other one which is behind does not, or may partially or completely receive the sunlight. The one in the middle casts a shadow on the one which is behind. This phenomenon is called eclipse, right? Thus eclipse are the examples of formations of shadow in the nature. Now next we see what is lunar eclipse. First, when earth comes in between the sun and the moon, see, this is what you need to know, that it is the earth which comes in between the sun and the moon, right? So it is the earth which comes between the sun and the moon, and the earth casts its shadow on the moon, then it is called lunar eclipse, right? Then it is called lunar eclipse. It occurs on a full moon day. If the shadow of the earth covers the moon completely, you can see a total lunar eclipse. When it covers the moon partially, you can see a partial lunar eclipse. It is not dangerous to watch a lunar eclipse because moon does not emit its own light. right? See, this is the diagram of that. You need to practice this diagram. You see here, children, penumbra is there, and at the center there is umbra, right? At the If the moon is at the umbra region, then there will be total solar eclipse. Okay. Now, sorry, lunar eclipse. Now we come to solar eclipse. When the sun, the moon, and the earth come in a straight line, the moon is at the center. It is called solar eclipse. The moon blocks the sunlight and casts a shadow on the earth. During a solar eclipse, if we are in the shadow, in this shadow, we will not be able to see, right, the part of solar disk which is covered by the moon. A solar eclipse takes place only on a new moon day. Remember, right? Lunar eclipse occurred on a full moon day, but a solar eclipse occur only on a new moon day. Right, children? And see, this is the diagram of the solar eclipse. That is dangerous to look at the solar eclipse directly, even if you have sunglasses or smoke glasses, because harmful rays of the sun can damage your eyes. Right? So, it's very harmful, very dangerous to view the solar eclipse. Then, now we are into some words for the great Indian scientist C.V. Raman. He was an Indian physicist who carried out crucial work in the field of scattering of light. He was awarded Nobel Prize for Physics in the year 1930 for his work on scattering of light and Raman effect. Right? He discovered that when a light travels across a transparent material, there is an evident change in the wavelength of light. This phenomenon came to be known as Raman effect. He was also awarded with Bharat Ratna. National Science Day is celebrated on 28th February to commemorate the discovery of Raman effect in the year 1928. Right? So, sir, we salute C.V. Raman for his contribution. And on that note, I stop here because the chapter has ended. And I hope you enjoyed it as much as I did. And until we meet again, it's a goodbye.